Okay, so we are back with our example 2 video working through the notes on finding inverses algebraically, and we've been using these 6 steps listed on the front in example 1, which was linear and cubic functions. Now we're going to apply those same 6 steps to finding inverses of radical functions together. So in this first example A here, we have a cube root of the quantity 2x minus 1, and our first step is to see if this passes the horizontal line test to make sure that there is in fact an inverse that is a function. And a cube root, it graphs a sideways wiggle, so we know that that does in fact pass the horizontal line test. Okay, so then we're ready for step 2, which is to replace this function notation f of x with y equals. So we'll have y equals the cube root of the quantity 2x and then minus 1. Okay, then step 3 is to switch the x and the y, those positions. And so we'll have x is equal to the cube root of the quantity 2y and then minus 1. Okay, and then step number 4 is to solve this for y. So I'm going to go ahead and add 1 to both sides to move that constant over, and I'll have x plus 1 then is equal to the cube root of the quantity 2y. Okay, to undo a cube root, we have to do the inverse operation, and the inverse of a cube root is a cube. So I'm going to raise both sides of this equation to the third power. Okay, and then we have to be very careful over on this side because the cube here on the outside, that is over a binomial, so we cannot, definitely not distribute that exponent over that binomial, right? That exponent means we have an x plus 1 times another quantity x plus 1 times another quantity x plus 1. We don't need to multiply that all out. We're just going to leave it exactly like we see it here as x plus 1 quantity to the third power. And then on this side, the cube and the cube root, they undo each other and bring out the 2y from underneath. So then to get the y by itself, we're going to go ahead and divide both sides by 2. And so this would be written as 1/2 times the quantity x plus 1 cubed is equal to y. Okay, and the reason that I pulled that 1/2 out instead of leaving it over 2 is because now it's in transformation form. So I can see from my transformation form that this graph of the cubic has been shifted 1 unit to the left and then dilated by a factor of 1/2, which would be a vertical shrink. Okay, so now I'm going to do my step 5, which is to replace that y equals with inverse notation. So f inverse of x is equal to 1/2 times the quantity x plus 1 cubed. Okay, now my step 6 on the front here is to restrict the domain if needed. And when I look at my cube root function, the domain and range of a cube root are all real numbers. So the domain and range, of its inverse will also be all real numbers, so there's no need to restrict anything in example A. Okay, now in example B, I'm starting with a square root function instead of a cube root function, and that square root function, if I were to sketch it, it has a k value of -3, so we would move down 1, 2, 3. That would be my end point, and then it's got a horizontal shrink of 2, but I'm not as worried about that as I am about what the domain and range are of this function. So just a real rough sketch, I can see that my function's domain is 0 to infinity, half-bounded, and that its range, so I'm just going to jot down here that the domain is 0 to infinity. okay, and that the range of this f of x function is from -3 up to infinity. So -3 inclusive up to infinity. Okay, that's going to be important when we get down to restricting the domain at the bottom, and we'll see why that's necessary as we work our way through here. So back to this picture of my square root graph, it passes the horizontal line test, which means that its inverse is going to be a function. So we'll go ahead and excuse me, find the equation of that by replacing this f of x notation with y equals, and then switching the x and the y. So we'll have y equals the square root of the quantity 2x minus 3, and then when we switch this x and y, that gives us x is equal to the square root of the quantity 2y minus 3. Okay, now to solve for y, I'm going to add that constant of 3 to both sides, and I'll have x plus 3 is equal to the square root of the quantity 2y. And then to undo a square root, we are going to square both sides. And just like with the cube of both sides, we cannot distribute that square over the binomial, so we'll just leave it written as it is. X plus 3 quantity squared is equal then to 2y. And to get the y by itself, we're going to divide both sides by 2 and then use our inverse notation instead of y equals. So f inverse of x is equal to 1/2 times the quantity x plus 3 squared. Now, the problem that we're going to run into here with step number 6, which is to restrict the domain if needed, is that now it is needed. Because what we started with was a square root function, right, that graphs half of a sideways parabola, but what we ended up with in the equation is a quadratic function, right, and that graphs a whole parabola. So in order to get the shape that we need for this inverse, we're going to need to restrict the domain, okay, and since we switch the x and the y, and x is our domain and range is y, that means that the inverse is going to switch the domain and range. So the domain of my inverse is whatever the range of my original function was, which was a -3 to infinity. And so the inverse equation is 1/2 of the quantity x plus 3 squared, but only with a restricted domain of -3 to infinity. Okay, and I'm going to switch over to Desmos here real quick to show you what that looks like on the graph. Okay, so here we are in Desmos, and we're going to go ahead and take a look at our original function. F of x is equal to the square root of the quantity 2x and then minus 3. And there's our graph of that square root function. Okay, then our inverse that we just came up with, we'll enter that as g of x. Okay, and g of x is 1/2. Whoops, got carried away, forgot my equals. So g of x is 1/2, and then times the quantity x plus 3, and that's being raised to the second power. Excuse me. So now when I take a look at these two graphs, I can see right away that they do not have symmetry about this line y equals x, because the red graph, the square root function, is only half of a parabola, right? The blue, my equation for the inverse, is a whole parabola. So what I have to do in order to make these work, make them have symmetry over the line y equals x, is I need to restrict the domain of my blue function so that it only graphs the half that I want to see. And the way that we restrict the domain in Desmos is we put a curly brace there, and then we're going to say that our x's, we're only going to graph this, for x's that are greater than or equal to -3. And then we'll close that curly brace and press enter. And now we can see that we do have the symmetry over this dashed line y equals x that, that we wanted to see for a graph of a function and its inverse. So by restricting the domain, we end up with the half of the parabola that is a reflection over the line y equals x, with the original f of x equals the square root of the quantity 2x and then -3. Okay, so that brings us back now to example C, and I'd like you to pause the video and try this one on your own, and then once you have had a chance to try that one, then come back and restart the video and we'll check it together. Okay, so in example C, we have a square root function, and I know that my square roots are going to come up with inverses that are quadratic, and they'll require a restriction in the domain. So before I start looking for the inverse equation, I'm just going to make myself a quick sketch to figure out what is the domain and range of this original. Okay, and I can see from my transformations here that this was shifted 6 units to the left. So I would come over here, 1, 2, 3, 4, 5, 6 units to the left would be my end point. And then this negative that's under here, that's my B. So that negative tells me that there's been a reflection in the y-axis, and so my graph is heading off this direction. So my domain for the parent graph would be -infinity to -6 inclusive, and the range for that graph would be starting at 0 inclusive and heading up to infinity. So the range of my original becomes the restriction on the domain of its inverse. So now I know that my inverse, when I find that equation, its domain is going to need to be restricted from 0 to infinity. Okay, so I'm going to do my steps now to find the equation of that inverse by substituting that function notation with a y equals. So I'll have y equals the square root of the quantity negative quantity x plus 6. Okay, then my next step is to switch the positions of the x and the y. And so I'll have x equals square root of the quantity and then negative quantity y plus 6. Okay, and then I want to solve for y. So to undo this square root, which I have to do that first because everything is under that square root, I'm going to need to square both sides. And so that will simplify down to x squared is equal to negative, and then times the quantity y plus 6. Okay, then I'm going to divide both sides by -1, and I'll have a negative x squared is equal to y plus 6. And then to get the y by itself, I'll subtract that constant of 6 from both sides, and negative x squared minus 6 then is equal to y. So my last step then, since I've already restricted the domain, is just to put my inverse notation back in. So f inverse of x is equal to negative x squared minus 6 with a domain restriction of 0 inclusive to positive infinity. Okay, and this brings us to the secret question for our lesson on equations of inverses. So for the secret question on your own piece of paper, you're going to find the equation of the inverse for the function that's shown in this graph. So you're going to be putting together the skills that we learned from our last lesson on transformations of functions, where you learned how to write the equation of this graph, and then combine that with what we just learned in this lesson on how to take that equation of the function and come up with its inverse equation. Okay, so go ahead and work that out, and then you'll upload the answer to this secret question when you attach your notes to Schoology for this lesson.